today? Does anybody have any problems with that? No? Comments, concerns? Yeah, there's like a couple here and then this whole row. Yeah, you're good, Alexis. Thank you, though. That's nice. No questions on the warm-up? Because honestly, if you can't simplify an expression, who are we kidding? We can't solve for x. So squeak now, please. No? We're good? No squeaks? Uh-oh, wall ball. Oh, good, maybe not. All right, so yeah, let me just run through the goal for today. Our goal for today is to solve for x in a linear equation. So what that means is kind of doing, 2 or 3 steps to isolate x. I'm also going to show you today 2 different ways that you could check to solve for x at the very end to see if you got the answer right. I guess this would always be in addition, of course, to flipping to the back of the book. But, these are some algebraic ways that you could also check your responses. So let's get started. To not overwhelm you, we're going to go ahead and give you a step-by-step process that always works when we try to solve for x. So I'm going to screen shade part of this guy here. That's some homework I went over earlier. Okay. Now, you only need to write these steps one time, but I do want you to write them down. That way you have them to refer to as you're working through your assignments for tonight. Come on, screen shade. There you go. Okay, so in general, there are 3 steps that we use to solve for x when we have a linear equation. Just a little heads up while I see you guys writing your notes. Don't forget our rules. If you don't understand it, you don't write it. That's rule number 1. Rule number 2, you must copy what's on the smartboard. What's on the smartboard must go in your notes. You're actually getting your first notebook quiz for me next week. I think it's going to be next Thursday. So, preview of coming attractions. I could say to you, turn to our example 1 notes from section 1, 2. Please copy the 3 steps that we use to solve for an equation as indicated in part A. So that's like a popular notebook question. And then I'll just leave 3 blanks and you write down your 3 steps on to the next. So please keep in mind though, what's on the smartboard, even the verbiage, must go in your notes. So step 1, when we go to solve an equation, we want to simplify basically the whole problem. You want to simplify the left side and right side of the equal sign. In step 2, our trick is to move all the variables, the things that have the letters in them, to one side of the equation. And then lastly, step 3, we do the reverse order of operations. We SADMEP. In other words, you solve by first undoing any subtraction or addition, then any division or multiplication, then any exponents, and then any parentheses. SADMEP, by the way, you know that that's just the reverse of the order of operations. I don't know if you've ever been taught it that way or not, but that's the way it is, whether you noticed it or not. When we solve by undoing, we're trying to peel off the layers to get down to the x. The order in which you peel off those layers matters. You can't just do it any way you want. And the order that we do those to peel off those layers to get down to that x is the reverse of the order of operations. It actually makes sense if you think about it. Because when you simplify an expression, bring it together to find a value, you use the order of operations. But if you want to peel stuff off to isolate a value, you got to go backwards through that process. So if you think about it as the backwards of the order of operations or the reverse order of operations, it actually helps you, proceed in a more correct fashion. So after you do step 1 and step 2, you're going to be commonly left with an equation like in part A. So you see I have all the variables left on the left side there, and then there's nothing I could do to simplify that. I can go ahead and now solve this equation, 3x minus 6 equals 0, by adding 6 to both sides. So I basically undid any subtraction or addition that I saw in the problem. I undid the subtraction, once again, by adding 6 onto both sides. So the subtraction right here, I added 6 to both sides. And then you always want to balance the equation. So we balance the left side of the equal sign, and then we balance the right side of the equal sign. So left over on the left side, we have 3x, and then 0 plus 6 is 6. Now I have to undo that 3 times x. I have to get rid of that 3, right? So in order to undo the multiplication, we just divide both sides by 3. Dividing both sides by 3, 6 divided by 3 is 2. So we get an x value of 2 for what looks like is my final answer. If I want to check to make sure that x equals 2 is the solution to 3 times some number minus 6 equals 0, if I want to check to make sure that 2 is that answer, all I do is I substitute that 2 in. So wherever I see an x, I put a blank, and I substituted my 2 in. So 3 times 2 is 6, take away 6 is 0. It totally worked out. And we basically do the exact same process for part B. So we'll go ahead and show you that a little bit. You'll see that this time we have variables on both sides of the equal sign. So I didn't have to do step 1. I didn't have to simplify both sides of the equal sign. They are simplified. You can't combine any of those. There's no like terms. So what I went ahead and did is I proceeded to step 2, move all the variables to one side. And it was a positive 3x sitting over there on the right. If I want to move all my variables to one side, quite simply, I just subtract 3x from both sides. Remember, you're always following your golden rule of algebra, like the golden rule of, I don't know, life, right? Do to one person what you would have done to you. Is that reciprocity there, yeah? Okay, well, in algebra, we have that same thing. You got to do to one side of the equal sign as you do to the other. So we subtract 3x from both sides. 5x take away 3x is 2x. So we have 2x plus 4 equals negative 8. Subtract 4 from both sides. So we get 2x equals negative 12. And then if I want to undo that multiplication, I have to divide both sides by 2. So x ends up being negative 6. You could check that by substituting this x value of negative 6 into your equation. It turns out you could still generate a true statement, so it does work. You're all writing, which is great. Remember, I take that as a cue that you understand what you're writing. They may not understand what they're writing. Looks like you're doing a good job. Oh my gosh, some of you are already into the independent practice. Okay, so you can go ahead and flip that page. There's 2 problems for you to try on your own to make sure you understand our 3-step approach for solving for x. So I'm going to go ahead and check off a couple more homework assignments. So just to go over your independent practice responses, for part A, you should have x equals negative 4. And then for B, you get x equals 8. Okay, are there any questions about that? So you might have noticed in the next example, because some of you actually already got a jump start on it, in the next example, what we actually end up doing is all 3 steps. So I just wanted to talk with you briefly about how that, first step actually comes to play out when we're looking at these problems. In example 2, we have a little bit more to our problem. We have 6 times the quantity of x minus 1 plus 4 equals 3 times the quantity of 7x plus 1. Please keep in mind that if you see parentheses or like terms, you have to do that first step. You have to simplify first. So that's actually what I have to do to get off to a good start on this problem. I actually have to do the first step. I have to simplify both sides of the equal sign. So I am going to go ahead and distribute the 6 in, and then the 3 in. And now I can move on to step 2. Almost. I just looked up. Forgot about that guy. Negative 6 and 4 are also like terms. So now I can simplify this. There we go. Now I'm all simplified and good. Does everybody see how you simplify? You use your distributive property and combining like terms for that first step. All right, now we can go ahead and move all of our variables to one side. And I'm going to always move the thing that has the smaller coefficient because I always like to work with positives. And then we have negative 2 equals 15x plus 3. And now all my variables are on one side. To finish off the problem, what I normally do is I go backwards through the order of operations in step 3. I'm going to go ahead and undo any subtraction or addition that I see in the problem. So I see addition of 3, which means I need to take away 3 on both sides of my equal sign. That's going to give me negative 5 equals 15x. And remember, there's a times sign in between. Multiplication is implied when there is no symbol. So I undid my subtraction and addition. Now I have to undo my multiplication or division. I'm going to undo this multiplication by dividing both sides by 15. So now we get x equals negative 1/3. Don't forget to leave your answers in lowest terms. If you fail to reduce, you know I take a little bit of credit off for that, so watch out. Got to leave your answers in lowest terms. Completely simplified, if you will. Okay, so I wanted to show you another really cool way to check your answers. This will be super helpful for you the whole semester long. So you will really like this. If you have your graphing calculator with you today, you do want to take a second. Go ahead and take it out. I'm going to show you a pretty cool trick for checking your solutions on the graphing calculator. So you're going to open up your graphing calculator and you're going to go to your y equals screen. And do you see what I typed in y1 and y2 there? In y1 I just typed in the left side of the equal sign. You're probably saying, Mrs. Lucas, why are you showing us this with this problem? Well, you got x equals, what, 1/3 or negative 1/3, something like that. Like plugging in those fractions can be really annoying. So, you know, you still want to be able to check. This is a great way to do that, even when you get messy numbers and messy answers. So you'll see in y1, I went ahead and I typed in the left side of the equation. And then you see what I typed in y2? The right side of the equation. What we're actually finding when we solve these equations for x are the x values that these two things have in common. We're finding essentially the place where these two graphs meet. So it's really, really helpful to put y1 on as your left side and then y2 as your right side. Then what we're going to go ahead and do is we're going to press graph. And you're going to see two lines appear on your calculator. Notice that they meet. When our graphs meet, that means that there is a solution. If the graphs don't meet, you're not going to have an x value that they have in common. So what we're going to do right now is we're going to have our calculator do a little bit of the legwork to figure out where do these x values meet. What x values do these two graphs have in common? In order to get that to appear on your calculator, you should press second and trace. That's the calculate menu. And I just said it. We're going to find the point where these two graphs meet. So my very smart period 6 college algebra class, I have a question for you. Which of these wonderful options up here will help me identify the place where my two lines meet? Chris? Option 5, intersect. Okay, and you just have to enter 3 times. First curve, second curve, guess. Yes, you do want to guess. And bam, there it is. You see that? X equals negative 1/3. That's what we got for our problem. You see that? X equals negative 1/3. So it is super handy to have this as a tool to check. I went ahead and I checked this problem graphically and I saw that this answer here matched this answer down here. I got negative 1/3. We found the x that they share in common. Questions about that? Yes. Sure. Okay, so that you might not be the only person who had that problem. I'm going to go over that with the class. In your y equals screen, look at the top of the screen. Plot 1, plot 2, and plot 3 should be white, not black. Are yours black? Huh. All right, then I got to come over because that's real common. If your stat plots are on, it's going to try to pull information from L1 and L2 instead of your XY screen, and it'll give you an error. So let me stop over. Okay, my college algebra class, you have an independent practice. I want you to go ahead and try that. And furthermore, I'd like you to check it by using your calculator. When you go and check, if you substituted it in, that's fine. If you could take a second and throw it in your calculator. The trick on this last problem, though, when you check it on your calculator, you might have to zoom out a little bit because the lines almost look parallel when you graph them. But if you zoom out, you see where they meet. The second calc, option 5 option still works even if you don't see the point of intersection on your screen if you have a newer model calculator. If it's an older model, it may not work for you. The people at home. Independent practice 2, x should be 26. Did anybody not get that algebraically? I'll walk around and troubleshoot calculators here in a sec. Algebraically, did anybody have trouble with 26? We're all good with that? Okay, so that sort of sets us up pretty nicely for where we need to be for tomorrow. I'm going to go ahead and let you kind of finish up just by copying down a couple of definitions real quick, your x-intercept and your y-intercept.